Welcome to the Digital Tutors, and today we're going to be doing chemical equilibrium. So again, this is May June 2026, paper 2, physical sciences. So let's start right away without wasting of time. Iodine gas I2 reacts with chlorine gas in a cell container. Temperature T equilibrium is reached according to the balance equation, and then delta H is said to be less than 0, so the forward reaction is exothermic, I2 3Cl2. So this is our reaction. The graph below is drawn versus mass versus time T. Okay, so we're going to start now. 6.1 says the Chateliers principle. So the Chateliers principle says that uh, in a in a closed system, or if a disturbance occurs in a system, let me use this one. If a disturbance, so it says that if a disturbance occurs in an isolated system, the system the system will oppose the disturbance to establish a new equilibrium. That is it from me. So you can find a more accurate definition, although we know what Chateliers principle is talking about. So if we disturb a site, the system opposes that disturbance of the reaction. 6.2, why are the masses constant and temperature T2? So temperature T2, the masses are constant because we have reached a new equilibrium, because a new equilibrium is reached. The rate of the forward reaction is equal to the rate of the reverse reaction. So that's because a new equilibrium has been reached. So 6.3, at T1, the pressure is adjusted. Okay. So right away, I need to check what has been favored. So IC2 has been the one that has been favored. It's the one that's showing an increase, while the other ones are showing decrease. Okay, that's okay. So I need to check those sides. The sides, what are they? Are they the... So if you can check here, you have 1 plus 3. So we have 4 molecules here in total, while the other side we have 2. So it's 4 is to 2. So this is based on the fact that I just made an adjustment to the pressure. So 6.3, we need to deal with it accurately. So here we know if we're changing the volume of the container, what do we need to do? Was it increased or decreased? So I need to check what actually happened. As I checked, I looked at the side that was favored. The side which was favored was the forward reaction with the least number of molecules. So here, what is it? Pressure actually, what is it? They say was the volume decreased or increased. So the volume here was actually decreased. So the volume was decreased. So you need to choose decreased. The reason being, you must understand that the only case whereby we'll have a decreased, according to the Chateliers principle, uh, an increase in pressure occurs by decreasing so we have decreased volume, and then we know an increase in temperature. An increase in temperature favors an increase in pressure favors the reaction site where there is more molecules. Where there's more molecule, no, it has to be where there is less, where there are less molecule. What actually happened here, the forward direction was favored. As we can see, this was the direction that was favored, was the one that was increasing. The forward direction was favored. Was favored. Add T1. Okay, I think that will be all. And then we have explained our answer 6.4. What other change to produce similar change to T1 to favor the forward direction? We need to actually, we know delta H is less than 0. So if delta H is less than 0, we need to favor, we are trying to favor the forward direction. So we know the forward direction is exothermic. So an exothermic is favored by decreasing temperature. So decrease the temperature or decrease in temperature. Decrease the temperature. So this is the change that can be made. decrease the temperature T. I think that should be all. And then now, without a waste of time, we're going to go to 6.5, the final blow of the session. So 6.5, the things that are happening there. So the volume of the container is said to be this at T2, time number 2. So the concentration of the gases are this and this. More I2 is now added when a new equilibrium is reached. The concentration is this. Kc is still remains the same. Concentration at equilibrium is this after we reach a new equilibrium. So the volume of the container, so at T2, okay, when we look at T2, so that's going to be what? At T2, that's going to be our new equilibrium. But unfortunately, that's going to be our initial, since we had more, what is it, more I2 that was added. So more I2 was added. So when more I2 is added, it means that it's going to actually increase, and then it will now pose this change. Of course, this will be aligning with this also. No, it won't go like that. I think it will go in a manner whereby I think it will just go like this a bit. While this one will go and favor the forward direction. So we need to reach a new equilibrium somewhere there. So a new equilibrium was reached after that. So without a waste of time, let's draw a rise table. We know what we're dealing with. This is the Kc calculation rise. Okay, I will draw that quickly. And then also going to write down the C part where C is equal to N over V. So I'm going to now just write that down quickly. So we have 3 of this. Then we have rice. We're going to start with what do we have? We have I2, and then we have Cl2, and then we have 0. What is it? ICl3. Okay, then I will draw the other sections also. And then rice, so we're going to have R, which a ratio is going to be how much? We need to check the ratio there. We have a ratio of 1, and then we have 3, then we have 2. And they said that at equilibrium, something happened here. When a new equilibrium is reached, I have an amount that is there, which is 0. What is it? Concentration of 0.03. So this is going to be the concentration at equilibrium 0.09. So C is equal to N over V. And the Kc also. So writing that Kc formula, it gives you some marks also. So I'm going to say concentration of product, which is going to be squared, divided by concentration of reactants, which is I2, and then to the power of 1, then multiply by, what is it, Cl2, all to the power of 3. Then without a waste of time, I'm going to start to fill the table quickly. So initially, this is what happened. We had an amount of 0.05, 0.05. So already there's some amount here on this equilibrium. This is continuous 0.05. And then we had equilibrium number of moles here. So we can calculate this by multiplying the volume. So of which this is going to give me 0.18. 0.18 will be my 0.18 And then don't forget to add the plus here and then the minus this side. Since now we know that we have just increased this amount here. It means that this is going to be favoring the forward direction while subtracting these two. So that's why we have minus and minus there. Okay, equilibrium, we'll just add this to get our equilibrium. So how much is this going to be? I have 0.18 as equilibrium. I'm going to subtract 0.18 minus, is that correct? No. I need this for concentration, initial concentration. So I need number of moles here, initial moles. This is supposed to be 0.1 positive and then 0.18 down here. Then I'm going to get 0.08 here as my, because this is going to be concentration, concentration, concentration. So we need to convert this into what is it? Into number of moles. Converting that, this will be according to C is equals to N over V. Then concentration is 0.05. And then you're going to multiply with the volume, which is 2. Then you're going to get your number of moles. This will be for ICl Cl3. And then you'll be okay with the rest. So we have gotten this amount. So molar ratio will work on the change here. Already the ones we can fill them. So we're going to start filling the other one. 0.15 initial I had 0.15 multiplied by 2 will give me 0.3. And then the other one will give me 0.36 multiplied by 2 will give me 0.72. And then from there, the minus now. And then be careful here now using the molar ratio. 3 whatsoever, so we know how much this is going to be. 0.0, we're going to have 0.12 here using the molar ratio, and then we have 0.6, and then this one is going to be 0.04. Okay, and then we have 0. Okay, we are not yet including something there. So let us listen to the statement. More I2 was added. What does that mean? It means that you're going to add an amount that is not known there. And they ask you to calculate the number of moles of I2 added. So more of this was added. So when you subtract this, to add this, you're going to get 0.26 here, and then plus X, which is going to be in equilibrium. I'll have 0.26 here. Then plus X divided by 2, which is the volume concentration, is equal to N over V. This one is going to be 0.6 divided by 2, which is 0.3. Okay. Some of you are going to make a mistake of adding everywhere here, plus X, plus X. You're going to mess this whole up. So you only add the amount that has been added on that, according to that table. So here I have, what is it? I have Cl3. Okay, the Kc was given to be 0.357. So I have 0.357 there. And then concentration of this is 0.09 all squared and then divided by I2. This is going to be 0.26, then plus X divided by 2, and then multiply by what? Multiply by Cl2, which is 0.3. Cl2 is 0.3, then to the power of 3. Then solving for X here should be simple. You can see they're doing the math 0.26 and then plus X. I'll have 2 multiply by this. Multiply by 0.09. all squared divided by 0.3 all squared multiplied by 0.357. And then minus 0.26. Minus 0.26 both sides. Let me just leave it for this now and then. So this x should be the amount which is 2 multiplied by 0.09 all squared divided by 0.3 all to the power of 3 multiplied by 0.357 and then minus 0.26. So this x is the number of moles that were added, mind you. Made them to be x. I used the number of moles to calculate this. Punching the calculator, this is going to give me 2 by 0.09 all squared 0.3 all to the power of 3 multiplied by 0.357 and then minus 0.26. I'm getting 1,52. 1,52, 1,42 or 1,421. In most, that's the amount that I'm getting. Okay. Then we have found our answer, which is done for us. And then thank you so much for tuning in to us. We're here.